An electrolytic cell is designed to produce pure copper from copper sulfate. An increase in which of the following cell conditions will most effectively increase the rate at which pure copper is produced? So first of all, an electrolytic cell is a non-spontaneous cell where you are basically driving electrons from the anode, the site of oxidation, to the cathode, the site of reduction, against an electrical gradient, right? Where essentially the anode, in this case, which is always the site of oxidation, is positively charged, okay? And the cathode is negatively charged. So if we were to draw the standard setup, right, if this is the anode and then this is the cathode, in this case, in an electrolytic cell, the anode is actually positively charged, right? So the electrons want to stay there, right? But the cathode is negatively charged. And so to make this happen, it won't happen spontaneously, right? This is thermodynamically unfavorable. The delta G of this situation is positive. But to make it happen, you need a external current or some sort of energy source driving this process, right? Now, here they're asking us what is going to make pure copper deposit at a greater rate, okay? And the pure copper here, when we're talking about producing pure copper, so copper metal, we can only do that from copper sulfate, which is producing like copper cations. We can only do that if electrons are coming in and reducing that copper, okay? So the cathode here must be copper 2+, okay? Because if you're in an electrolytic cell, the electrons are going to the cathode, right, where they are reducing whatever cations are there into pure metal, all right? So that's how you actually produce pure metal. And what is that going to be affected by? Well, it's not going to actually be affected by the concentration of the sulfate, all right, because that isn't really playing a role in this reduction reaction. However, the current of electricity, which is a measure of basically the movement of charge per time, is, okay, because the movement of charge is the movement of these electrons, right? And so if you have more electrons moving into the cathode, there's going to be more electrons combining with the copper cation to produce the copper metal. So B here is going to be the only thing that actually increases the rate of the pure copper. The size of the two isn't going to matter, okay? So B is the right answer.